Patient Information System. Group member Ahmed Abdurrahman Gamil, the leader. Abdullah Hashim Ahmed Abdullah and Muhammad Hassan Ali Al Jumai. The introduction. The Patient Information System is a C++ application designed to manage and organize patient data. Functionality it uses data structure search as stacks, binary search, tiers, and errors to support core operation, including editing, updating, deleting, and searching updation records. Additional functionalities like on-to sorting, algorithm binary search, and fill input output enhance the system performance and usability. This project highlights the practical application of object oriented programming and algorithm design in managing healthcare related information. And now this is the synopsis. The patient management system in C++ uses a queue to manage patient flow and records. Key features include editing, deleting, updating, and searching for patient by ID without full input validation. It also supports sorting by name without advocating queue order. The system check for errors like declared IDs, queue overflows and underflows, and private a user friendly menu driven interface. Work distribution. Ahmed Abdurrahman Gamil, his responsibility system design, implementation of core functionalities, NQ, DQ, and update. And Abdullah Hashim Ahmed Abdullah, his responsibility implementation of search and sort, algorithm, BST, integration, and fill handling. And me, Muhammad Hassan Al Jumai, user interface input validation, Indo functionality, and presentation preparation.
Now I will be demonstrating our project. How does it work and its functions and so on. So let's get started. As you can see, our patient information system, this is our screen. Our system has many operation and we used the queue as the main data structure, especially circle queue because it is the most appropriate data structure type for our project. So our project has insert, which is queue operation, and it has dequeue, which serve operation, and we has many searches types, many sorting types, and we have binary search tree, and we used as well a file to save data and to load data and so on, and I will be demonstrating now. The first rubric, it is the execution, and our project has zero error and it is 100% correctly working. So this is the interface and we will be showing you every choice what it can do. As we can see, this is the first option. It is any queuing operation, which is adding a new patient. You have to enter some details, name, age, insurance, and you got successfully entering. For deleting, you have to just enter the ID of the patient and it will be deleted successfully. For updating a patient, you have to enter his ID, the ID of the specific patient that you want to edit his details, and then it will be give you some inputs to enter the new data. And here we go. Your information has been updated successfully. For choice for it is linear searching. So it is we use the normal loop to implement this kind of searching. So you have to enter the ID and you get the required patient details. And we have here the bubble sort, and I have also other type of sorting I will be showing you right now. This is for displaying all the patients from the circled queue. So choice number 7 is the queue, which is when you serve the patient, it will be dequeued. It will be removed from the first line of the queue. So this is a basic operation for any queue. And this is the other type of sorting, quick sorting. And we have the binary search patient, and absolutely it must be sorting before handling it. And this is binary search, Traver, in order and pre-order and post-order. And this is saving any data to the file. This is a normal operation. And here's a load from file. It loads the data of the patient from the file, from the text file. It's normal operation. And this is undo operation. Uh, we use a stack for it. And the last option is to exit from the system. Now I will be demonstrating some user interaction and error handling because it is just 10 minutes and I will be show you in a quick glance. And here is some example of the operation. And here also we have if we input a character, you have to enter a number. And here for adding new patient, you have to enter like numbers for the ID, not characters. It is actually fully error handled, all the system. And as long as we are exploring any other functions, it is error handled. I We checked everything from deleting to updating, and for searching for a quick sort, you have to enter a valid choice. And here we have error handle for binary search, as you can see, and everything has been tested and we checked everything. Now let's move to the other rubrics criteria. Let's move to my friend Abdullah.
Now we will move to the class and object where we have well-structured and clear implementation of the object-oriented programming. As example here, we have the stack class where in the private we have the data members and we have the top and we have the capacity, and in the public we have the common functions for the stack. Of course, we have the constructor and we have the destructor and we have the push and we have the pop and we have the peak and we have the boolean of is empty or not, and of course we have the return integer of the size. Another example in our system of implementing the class is the binary search tree class. In this class, of course, we have first the private. In the private, we have the root and we have the max depth where it's constant, so we can change that. And we have also the insert function, and we have a couple of other functions like the find minimum and the delete node. And of course, we have the essential binary search tree functions, the in order and pre-order and post-order functions. And of course, they depend on the scenarios we want to implement each one of them in it. Also, in the public of the binary search tree class, we have the constructor and we have the destructor and we have also the remove and we have in order traversal and we have the pre-order traversal and post-order traversal and is empty. Additionally, we have the file manager class. This class enables us to save data to file and also load data to file. As we can see here, it's static, which means we don't have to create an object to use that class. And yeah, we have two main methods in the file manager class. We have the save to file and we have also the load from file. Moving on to the sorting algorithms class, this class combines all the necessary sorting algorithms that we need to implement in our system. We have, of course, the bubble sorting, and we have the quick sort, and we have the partition. And this is one of the .h files example in our system. This is the patient class, and we could see here all the private and the public data members and functions before implementing them in the .cpp file. And here in the main, we could see the patient class and the object we created from that class. The object we created, we named it the hospital system object. And of course, this object has all the features and the functions that we implemented in the patient class. And moving on to the next criteria, the searching. In the searching, we implemented both the linear and the binary search. The linear and the binary search algorithms, we combine them, as you can see, in the one class, and we name that class the search algorithms. And they are under one class, and this class is public class, so we don't have any private data members in it. And the type of both linear and binary search is static, which means, as we said before, we don't have to create an object for that class to use both functions. And here we have the binary search patient implementation. we could see here we implemented the method of the binary search patient by creating a vector of the patient, and it sorted it by the patient ID. And also we have the linear search implementation, and this function called the search patient, and it also similar to the binary search. It search for the user by his ID, but this time it used the linear search algorithms instead of the binary search. And next we go to the sorting criteria, where we have actually implemented more than 2 sorting methods. And similar to searching, also we combine all the sorting methods we want in one class, and we call that class sorting algorithms. In this class, we could see here we have more than 2 sorting algorithms. We have the bubble sort, and we have the quick sort, and we have the partition. And here we have the quicksort patient's code implementation. In the function, we could see that the quicksort patient it has 3 criteria that the user could choose one of them to sort. We have either by name or by ID or by age. And this is the implemented code for the bubble sorting. Moving on to the next criteria in the rubric, the binary tree. In our code, we have a fully functional binary search tree with all of its methods, like the insertion and the pre-order and in-order and post-order. As it's presented here, this is the binary search tree class. In this class, of course, we have the private members, like the root and the maximum depth, and the insertion, and also the find minimum and the delete node. And of course, the essentials, like the in-order and pre-order and post-order, and the destroy tree. And in our public area, we have the binary search tree constructor and the binary search tree destructor, and of course we have the remove, and we have in order traversal, and we have the pre-order traversal, and of course the post-order traversal, and checking the emptiness of the tree. Next criteria we have is the state stack or queue or list, where we have fully implemented the queue with a complete functionality. Here in the patient, we can see the implementation of the queue, where in the private we have the queue necessary data like the rare and count and front. And also we can also see in the public down the DQ and EQ and etc. As it's shown here, this is the full implementation code of the enqueue function, where here it asks for the patient basic informations like the patient age, name, and insurance number and phone number. And after it checks everything is alright, it will add the patient to the binary search tree and save to undo stack. And here is the DQ function in the patient. Of course, first it checks the emptiness of the queue. If it has no any patient, it will send a message of the message. It will inform the user that the queue is under flow and there is no patient in the serve. And if there is actually a patient in the serve, it will continue its job and will move the queue line to the next patient to serve. And next criteria here we have is the template, where we have many classes that implements the template. For example, here we could see the stack class, where it implements the template type name T. Also, same case goes with the binary search tree. And additionally, we have the search algorithms. And lastly, we could see the sorting algorithms. And lastly, we have the file. In the file criteria, we have one file that is useful for inserting or uploading the data from the file, specifically the patient data. This is the real life example of the file, which is name is patients.txt. This file shows the patient name and the ID and all other informations. And as we could see here, this is the file manager class, as we saw it earlier. This class, as we discussed, has two main functions, the save to file and load from file. The save to file, basically it divides the data into chunks that is divided by the line. So each patient info would be separated from the other info by a line. And here we could see the full implementation of the load from file, which use the vector as a way to insert the data from the file. After inserted, it add the data to the patient structure, which has the patient.name, patient.id, patient.age, and etc. And this was all for our system. Thank you for listening. See you in a goodwill. مع السلامة.